Now, as you can see that this type of passage is multiple paragraph passage. So in this kind of passages, you will find some link among the paragraphs. For that, you can also go through the idea of general to specific. That means some main idea will be presented in the first paragraph, and the following paragraphs may be specific details of the passage. So every paragraph will have a topic sentence of its own with a theme of its own. So going through this passage, I want you to press the pause button, scan the entire passage and look for the words that keep recurring in the passage. Okay, now you might have looked for words like kinds of crystal, ionic salts, electrons, anions, stack, cavities, again electrides again. So these are the words. So that means basically you can understand that the passage is something about the chemical or fundamental fundaments of ions. So let's start reading it. One of the simplest and best known kinds of crystal is the ionic salt. So this is our general word, and this is the specific of kinds of crystal. So one of the kind of crystal is ionic salts, of which a typical example is sodium chloride. So again we have got an example of kinds of crystal or anionic salt or ordinary table salt. The fundamental components of an ionic salt ions are atoms and molecules. So the fundamental components are atoms and molecules that have become electrically charged by gaining or losing one or more electrons. In forming sodium chloride, for example, again we are going to discuss on sodium chloride. Sodium gives up an atoms and becomes positively charged, and chlorine atom gains an electron, thereby becoming negatively charged. So when it gains an electron, it becomes negatively charged. The ions are attracted to one another by their opposite charges, and they stack together compactly like tightly packed spheres. There's a word spheres over here. So what I understand from this passage is this paragraph that we are going to talk in this something has been introduced like ionic salts and sodium chloride, how sodium chloride is formed and the properties. Now moving on to the next paragraph, what I get is recently scientists at Michigan State University created a new kind of crystal called an electride. So we are going to talk about electrides here. Here it was sodium chloride and here is going to be electrides. In electrides, the anions are completely replaced by electrons which are trapped in naturally formed cavities within a framework of regularly stacked cations. So who are trapped in the cavities? It's the electrons that are trapped in the cavities. Electrides are the first examples of ionic salts in which all these anionic sites are occupied solely by the electrons. That means the electrides are the only or the first ionic salts which are occupied solely by the electrons. So this is an important point for us. Now what we understand from this paragraph is that we are talking about the feature of electrides, the fundamental feature of electrides, which is that they are replaced by electrons. Moving on to the next one, unlike other type of anions, unlike is a contrasting idea, represents a contrasting idea. Unlike other type of anions, anionic electrons do not behave like simple charge spheres. What are simple charge spheres? We saw spheres something over here that they stack together completely like tightly packed spheres. So the anionic electrons are totally different from this. That means they are not tightly packed. In particular, because of their low mass, reason number A, and tendency to interact with one another over great distances, this is reason number B. They cannot be pinned down to any one location, so that means instead they wander close to and one among the atoms lining the cavity and interact with electrons in nearby cavity, perhaps changing places within them. That means they are highly volatile. So this is another feature of the electride. Okay. The first feature was they are completely replaced by electron, and second that they are highly volatile. Moving on to the next paragraph. The properties of an electride depend largely on the distance between the cavities that hold trapped electron. This is the topic statement. When the trapped electrons are far apart, now we are talking about the distance. So when they are far apart, that is our point number 1, they do not interact strongly, and so we have somewhat like an array of isolated negative charges. Now when they are closer together, point number 2, they begin to display properties associated with large ensembles of identical particles. When they are still closer, point number 3, the ensemble properties dominate and the electrons delocalize. What is delocalizing? They are no longer tightly bound within individual cavities, but are more or less free to pass through the spaces within the framework of positive ions. So what happens? The more they are close, they are more free to pass through spaces within the framework of positive ions. So this is talking about the distance and how distance affects their properties. Now by synthesizing electrides from a variety of material, one can vary the geometry of anionic cavities and their relation to the surrounding cations. The resulting properties may make it possible for electrides to become a basis for economically useful new materials and devices. For instance, so we have an example. The first is, because the electrons in some electrides are weakly bound, these crystals could be effective as photosensitive directors, in which an impinging photon liberates an electron, resulting in a small electric current. So this is how it can be utilized in number 1. Second, the same binding can make electrides useful in solar energy converters and as cathodes in batteries. Now we have the word 1. Obstacle is the tendency of electrides to decompose through reaction with air and water. This is a limitation, an obstacle or limitation of usage of the property of electrides. Researchers are seeking ways to increase their stability. This is what they are doing, but there is a limitation. So in general, if we go through and scan the passage, we have something in the beginning talking only about sodium chloride and its formation as an ionic salt. Then we come to a new kind of crystal, which is electride, and then we are talking about all the properties of electride in detail, and at the end this property has helped it to be economically useful. Fine. So this is the construction, the logical structure of the passage. Now solving the questions, we go to question number 1. The passage is primarily concerned with discussing what? Now as you know the logical structures, it's very easy to do this kind of question. The primary purpose, is it a way to isolate electrons? Is it telling us how to isolate an electron? Or is it telling us the characteristics of a new kind of crystal? Is it telling about the structure of all ionic salts? Is it only talking about the commercial uses or the properties of ions? Very easy to eliminate A, C, D and E, because this is not what is talked about, or they are details of the passage. The primary purpose is B, the characteristics of a new kind of crystal. So we go to the next question. In the first paragraph, the author is primarily concerned with, I'm sure you'll be able to manage this question to 80% of accuracy. So please press this pause button, read the options and eliminate the ones that you are sure are not the correct answer. I hope you all got it, that B is not a correct answer, because it says describing how chlorine atoms can become negatively charged. This is not the primary purpose of the paragraph. Describing some early research at Michigan State University is not mentioned in the first paragraph. Presenting the identifying properties of an electride is also not what is mentioned in the first paragraph. So you are left with A and E. Now, if you think of the passage carefully, as I told you, you will be easily able to get it, that it is introducing something, but it is moreover providing a background with the help of the sodium chloride example, so that you can understand the technical discussions that are about to follow of electrides, electrons, anions, cations and its properties. So E will be the correct answer and not A. Moving on to the next question. It can be inferred from the passage that the differences between the behavior in anionic electrons and normal electrons, the difference between the behavior of normal anions results from which of the following features of the electrons as compared to the normal anions. I want you to go back to the passage and read paragraph number 3 once again, wherein the answers we had already marked as A and B. So you will be able to see that the much lower mass of electrons and the much greater tendency of electrons are mentioned in that, but the much greater likelihood of electrons to remain trapped in naturally formed anionic cavities is not mentioned in the paragraph 3. So obviously your answer is C, 1 and 2 only. The next question. According to the passage, the defining characteristics of an electride is which of the following? So you will get that in paragraph number 2. If you have read it carefully, we have read it carefully. It says that it is completely replaced by electrons and occupied solely by electrons. You'll get the answer. It is E. Its negative ions consist solely of electrons. Moving on to the next question. It can be inferred from the passage that anions behaving as simple charged spheres. So what we talked about, what are simple charged spheres? A. Readily lose electrons and become positively charged, or B. Move freely in and out of their cavities. C. Respond to photons by liberating electrons. D. Stack with other anions to create a regular framework, or E. Remain fixed, that is fixed, relative to their cations. For that, we go back to the passage, and I told you that simple charged spheres are the ones that are stacked together compactly like tightly packed spheres. Means the ions are attracted to one another by their opposite charges. Okay, so if we have done that, we can see that the answer should be cations are positively charged, so they remain fixed relative to their cations which are positively charged, and anions are negative charged, so obviously opposites attract, so it will be E as the correct answer. It can be inferred from the passage that an electride behaves most like a normal anionic crystal when the electride has which of the following features? Okay, it behaves most like a normal ionic crystal when? Again, the answer lies in our previous question. They remain fixed relative to their cations, or the previous ones is negative ions consist, sorry. So the anionic cavities are widely separated is not the feature. All of the trapped electrons are able to delocalize again is not the feature. The trapped electrons are liberated by impinging photons is totally out of the context. The ions are tightly packed together. That is what is the simple sphere, that simple charge sphere. So D should be the correct answer over here. Solving the last question. With which of the following statements regarding electrides would the author most likely agree? I want you to pause the button, press the pause button, go through the option and eliminate the ones that are not the correct answer. It is an easy one and I'm sure you all will be able to do it. I hope you have done, and reading through the options, they have proven themselves to be of great commercial value. Is it describing the word great? No, it is not. So A is eliminated. The future commercial value is promising but uncertain. Okay. They are interesting but of no practical value is false. They have commercial value mainly on solar energy applications is again incorrect. The principal importance will lie in scientific research is irrelevant. So our correct answer is B, which says the future commercial value is promising but uncertain. Reason, there is a limitation mentioned in the usage that we did in the last paragraph. So B is the correct answer for the last question. I hope you have been able to understand how to go about in a reading comprehension, how to become active readers and how to solve the questions, how to understand inference by underlining, making arrows. So it creates a visual in your mind which helps you in solving a reading comprehension passage to the maximum accuracy. Thank you.